plant, and it provides information about the quality of the annotation. So usually, when we obtain function, how they perceive the germination stimulant. So here is an example on P. So RMS3 is the Ki2 protein from P. And so you have here four different patterns with the strigolactone. They will bind to the Ki2 protein, and then there are three important amino acids. The second step, then the Ki2 protein will hydrolyze the strigolactone, and they will release the ADC rings, and then the conformation of the Ki2 protein will change, and they will be active to perceive the germination stimulant. And Elena Danglars will give a talk later on to detail the work we are doing on that. So Ocumana population differ by first their genomic diversity, then their virulence, but also their aggressivity. And we do not forget this because some virulent populations are not so much aggressive, meaning that there are not so much plumage emerging on the sunflower. So Ocumana is mainly found from Spain to China. The first report is from 1866 in Russia, and they are rapidly spreading because of their tinicy. So as you can see there, it's look like powder. There are 2 micrometers of length, and they have been found recently in France in 2007 and in North Africa in 2010. And the first, this year, there is a first report in South America. So I had a personal communication from Guillermo Barea from Santa Cruz de la Sierra, and he told me that they found Ocumana in Bolivia, in this region, in Santa Cruz de la Sierra, and we will collaborate to describe the diversity of this population. And then we already, Belen already talked about that, the classification of the virulence, and it's a really similar situation than only with you. The virulence was differentiated with letter from A to H, A being the less virulent population, and it is deduced from the resistance of a set of differential sunflower genotypes. So here you have triplets. Okay, you have triplets there of line.
没有激光笔吗，小马？没有激光笔，那个指示那个怎么没啦？你就没个好的？没消失啥意思啊？不是，那个激光笔上有指示啊。哦，大屏吸光是吧
You can arrange a pointer if possible, because it's not good. He is
对呀、
going.
你把那个话筒给他们。
Yes. Yeah, at least something.
他那个电脑又动了。
You don't, I didn't realize. So this has been proposed by Leigh Monero Rees in 2015, but the situation for races with a virulence level higher than E is really unclear because we are talking about virulence F, F+, G, G+, G gonadal H, and so on. So we really need a new universal set of differential sunflower genotypes, and I encourage you to attend Friday at 2:30. Sandra Svegi will present the initiative of an international consortium. And how the virulence, what are the virulence evolution mechanisms? So they can evolve by point mutation, but also by recombination between populations. And the first talk of the Bombay workshop will, Leo Velasco from Spain, from CECI, will detail that. So I'm not talking about that. And concerning the genome sequence of Okumana, so it's a diploid genome of around 1.4 gigabases, and the genome contains 19 pairs of chromosomes, and Nicolas Pouilly produced the first assembly in 27 from the IN23 oculum, I don't know, race, and it has been collected by our colleague from CECIC, the Guadalajara Bible. So we assembled the 19 chromosomes, but as you can see, we have also large scaffolds that have not been assembled in the chromosome sequences, but since now we have also new genome sequences of higher quality with all the 19 chromosomes fully sequenced. Oh, sorry, I forget to talk about that. So here you have the size of the contigs, and as you can see in green, you have the human genome with very few repeats, and then in sunflower in red, right? Yes, sunflower in red, you have two main repeats, and it's the same for Kumana, and these two repeats are larger than in sunflower. So we wanted also to annotate the genome, so for that Philippe Delabo from Nantes University produced 60 RNA seq library from 20 different developmental stages from seed to flowering, and we used this RNA-seq data, and with Eugene integrative pipeline to Velasco are able to do genetic on Orobanche Kumana, so they are able to cross different populations of Orobanche Kumana. So they crossed IN12 with another population INA, and they produce the population from China have been collected and have been collected by Jun Zhao from Inner Mongolian Agricultural University, and so we genotyped 22 populations from Europe and China, and we selected 231 SNP common to all the population. And as you can see, we have a different genetic group. So one in France, one for Eastern Europe, one for China. So we sequenced 35 samples corresponding to 21 population, 6 from China, 3 from France, 4 from Spain, IN23 included, just to check false SNPs, and also to the resistance. What are the mechanisms of resistance to parasitic plants? So I encourage you to read this review from Marcus Albert from Germany. It has been published in Plant Physiology, and they propose this picture. So here you have the HR-OR7 gene that has been cloned in our group, and it is a membrane protein with intracellular kinase domain and extracellular within domain. And the CURE1 protein is similar to HR-OR7, and CURE1 provides resistance to seed by Belen yesterday. So there are 3 genes providing resistance to REST-G, and I will present you now the HR-OR5 resistant gene, and also the HR-OR5 that we OR7 and OR5 that we identify what we characterized recently. So concerning OR7, so here you can see that the gene provides resistance to RSF. It is encoding a receptor-like kinase, and as I told you, the protein is truncated in the susceptible lines. So now concerning the HR-OR5 resistant gene, here you have, so now we, instead of using back clones, we now fully sequence the genomes of the lines, because it is very easy and very cheap and very fast to sequence. So here you have the sequence of the region in the susceptible line, again, and we use 45 proteome as input, so the 36 Elianthus annuus and wild Elianthus, and also we added 9 other species on Strega mainly, because at the germination step, okay, you can provide resistant plants. So here is a first example. You have a mutation on the biosynthesis of Strigolactone. As you can see, there is no germination in the mutant, and it is clearly resistant. And then, more recently, they also identified another gene, and then the P10 genotype is susceptible, while the 8W is resistant. We go fast. So, concerning the germination, we evaluated many different species, and we want now to compare at the transcriptomic level the different accession. But it is for that we use 36 sunflower complete genome sequences. That has been produced by Alexandra Legendre in my group, Jérôme Gauzy and Sébastien Carrère. So we used 16 Elianthus annuus, 1 Elianthus anomalis, 3 Arbophilus, and so on, and also 1 tuberosus. So we used 20 genomes from 11 wild relatives. So we wanted to find the orthologous genes between the species, because it is really important to do that, to compare only the two main lines. So we found more than 3 million of genes, and we were plotted that the 40 genomes contain at least one gene common. Thibaut Rouder from my group will present you the use of intercrop to control Banque-Kuman. And with that, I want to thank all the collaborators, the funders, and with that, I thank you, and I will be pleased to take questions.